batteries included, you kind of take it out of the box and you're good to go. So sometimes the Python language is described as such. The standard library is pretty comprehensive. It contains stuff that most developers would need most of the time. You don't necessarily need to reach for other tools. You don't need to necessarily write a lot of code. So that's what I wanted to do here with Rec as well, to have this nice out-of-the-box experience. You don't need to reach out for other things to do common tasks. So let's take a look at how it looks like to work with Rec. So maybe we have an IX session and we can mix install Rec and call rec.get. So here I'm using the GitHub JSON API for the Rec repository itself. And this is what we would get back. So here we got the HTTP status 200 OK. We got a bunch of headers. It's more than these two. I chose these two for a very particular reason. And we got the HTTP body. And so the headers that I chose to show, so the first one is content encoding, which means that over the wire, the server sent the response compressed using this algorithm, gzip. And when Rec sees this header, it will automatically decompress it. And so, as a matter of fact, the servers don't really compress body by default. They would only do so when asked to, specifically when the client sets the accept encoding header. And this is what Rec does. So by default, it will ask the server to compress the body, so we save on bytes. And this is kind of the, so to speak, Rec approach. We try to use HTTP headers and do some, basically have opinionated defaults of how the client should work based on these headers. We also set some headers ourselves. So the other header is content type. So here it's application JSON. And similarly, when Rec sees this header, it will look at the value and try to automatically decode. So it did decode the JSON into Elixir map. So again, this call, what I like to often do is to access the body field directly. And then if I work with JSON, it's going to be automatically decoded. So I would reach for the key. So yeah, this is the description of the project. Instead of making the request directly, we can also first build up the request, maybe save it somewhere, and only later on actually execute it. So again, we have the same result. And the idea is that you would use these two different approaches in different circumstances. So maybe the first one, you're just playing with something or exploring API, having like a one-off line. This second approach is especially useful when you are maybe building up the request first with some basic options like the URL or headers, authentication, and then maybe later on you want to do a bunch of requests using the shared setup. So yeah, what are the batteries included? What are the features? So the first one, I would consider it as a feature. My goal is to have this nice high-level API. You just have a bunch of functions. You just call them, and it's basically it. Another feature is we have request body compression and automatic decompression. So we've seen the automatic decompression in action already. Here I mentioned that these features are implemented as using these steps. So we're going to talk about steps a bunch. So Rec by default supports the gzip and deflate compression algorithms. And if you install some extra packages out of the box, it will support Brotli and ZSTD as well. We support request body encoding and automatic decoding. So again, we've seen the decoding in action. We automatically decode the JSON. We can easily encode parameters as query strings. We have support for authentication. We even have the .NET-RC file, which is pretty useful for scripts and such. We can easily make range requests, follow redirects, retry when we face errors, raise on a HTTP error. So by default, we would get a response back, but maybe we want to raise if you actually got a HTTP error. We have very basic support for HTTP caching. That's something that I want to improve. We can set base URL. We can run against plugs, and we have pluggable adapters. So we're going to talk about these two later on. But rec by default uses the excellent Finch HTTP client. Finch in turn uses the excellent Mint HTTP client. So it's layers over layers over layers. So I mentioned that we have steps. So one of the goals that I had for rec was to have good documentation, and so we have this. So basically, all of the features are implemented as steps, and steps are just functions. And one of the nice kind of consequence of that is I can then document every step, every function as a separate thing. So here we have the follow redirects step. It accepts a bunch of options, like we can disable the automatic redirects, we can set max redirects. Here we also have code samples for this feature. And if you look at the sidebar, you will see other steps, and we have 3 kinds, which we are gonna talk about next. So if we have these batteries included, so to like stretch the analogy a little bit, let's talk about replaceable batteries. So we ship with a bunch of features, and let's talk about how we can rearrange these features or write new ones, how to basically write new steps, how to extend rec. So rec basically has 3 pieces: the rec module, the high-level API that we've seen, the rec request, which is what I like to call a low-level API. So this is the API that you would use to write your own steps or to add these custom steps to your requests. And then you have the rec steps module, which is just the collection of all of the built-in ones. So let's talk about the request struct. If we call this rec new that we've seen, so here just for the presentation, I'm passing 2 options, the URL and just the follow redirects to false. We would get back the struct. So we have the basic HTTP stuff, the method, URL, headers, and body. We would keep track of the options that were given. So here we store the follow redirects, and this is because, so this is so that the steps can look at the options and do some logic based on these. We actually keep track of all of the available options, and we're going to talk about that later on. We have halted, so this is kind of like the plug, con, halt, and adapter, which we are going to cover later. And now we actually keep track of all of the steps as well on this request. So by default, rec will put all of these built-in ones, but you can rearrange them as you wish. So these are the request steps. These are the steps that happen before making the network call. So this would be setting headers, setting body, setting a URL, and so on. We have response steps. So after we got a response back from the server, we would run these. And then we have error steps. So if instead of a response, we got an error, so maybe there was a timeout, maybe the server is not even there, we'd get an error, and then, yeah. So we also have private field, so just to store some arbitrary state between steps when you implement them. So let's kind of describe like basically how rec works on a very high level. So when we make this call, it is as if we would be building up the struct, and then we would be running steps on it. So here we set the default user agent, and so this is a step. This is a request step. And these take a request struct and they return it. So we would be kind of like piping them. So we would set some headers, maybe encode the body, compress it, and so on and so forth. And at the end of the request steps, we would call a kind of special step, which is the adapter step, so making the actual call. Again, we use Finch by default, and this step is just a little bit different. Instead of returning the request, it would return either of these 2 things. So that would be either the request response tuple or the request exception tuple. So in the first case, we would kind of take this tuple, and now we would be passing it through response steps. So again, maybe if there was an error, we would try to retry. If there was a redirect, we would try to follow it. decompress body, decode body, and so on and so forth. And in case of error, we would, again, take the tuple and try to maybe retry the error. So like on a very high level, this is roughly how it works. It's just passing data around. But obviously, it's not quite as simple to support use cases like following redirects and so on. So think about it that as if after calling each step, there is like a breakpoint, and rec basically kind of takes over and does some control flow. So again, we have 3 different kinds. Let's build a very simple step. So here we are just making a request to this website. Let's build a step that just adds some debugging statements. So a step, again, just a function, takes a request, returns a request. Let's just inspect the URL. And this is how we would use this step. We would use this rec request append request steps function to add it to our pipeline. So the append word is kind of important here. Again, steps need to run in a particular order. It only makes sense to decode the body after decompressing it. So we have appending to add them at the end. We also have functions to prepend them. So again, let's see the contract. So request steps, take a request, return it, response steps, take the tuple and return it, error steps. So with such a contract, we can actually go pretty far, but it is not quite enough to implement all of the use cases that I wanted. So a request step, instead of just a request, can also return this tuple. And here's an example. Maybe we have a step that tries to return a cached response. So we take the request, we look it up in the cache. If it was cached, we just return the request response tuple. And now what's going to happen is rec will no longer pass the request through the request steps because, again, like we don't want to actually make the request. So it will take this tuple and pass it through response steps. And similarly, a request step can return the request exception tuple. And so here's an example. Maybe we have a circuit breaker step. If the breaker is open, we don't want to make the request. We can just return the tuple with the exception. And we are not going to call any other request steps. We are going to call error steps. And similarly, response can kind of go into the error steps. An error can go into response steps, so we can have these flows. All right, let's try to do a demo. So there were a bunch of technical difficulties. Let's do live coding and let's hit the network. What could go wrong? So here I have a live book with just some basic setup, so you don't have to see me typing it. This is again the hello world. So it works. So let's do some minor changes. Let's change this HTTPS to HTTP, and GitHub is going to automatically redirect to use the HTTPS as one should, and rec picks it up. It says it is following the redirect, and so we have the same result because rec automatically redirected. Okay, so let's now do something else. Let's take this URL, and we're going to create the rec struct ourselves. So yeah, it's hitting the network part. Okay, yeah, we are good. So now what we can do is we can change this to base URL. So imagine you maybe have integrated with some API. You want to keep the base URL the same, but at each call site, you want to just use the particular part. So again, we have the same result, but now what we can do is maybe check out Finch. So Finch, Elixir HTTP client focused on performance, and I really cannot praise Finch enough. Basically, because it is focused on performance, I don't have to. I get all of the benefits for free. Let's check out something else. Let's hit this URL, like a bad URL. We got a nil, and the reason is we got the response, but the response didn't contain that key. So when we would call, when we would write code like this, it kind of expects that we got the successful response. So what we can do with rec is say HTTP errors raise. And now, if rec sees errors in the 400s or 500s, it's going to automatically raise. So this is kind of useful for, again, maybe you have one-off scripts, you don't want to do error handling, but you still want to have like a reasonable error. So there is quite a few options, and sometimes maybe you can mistype the options. So we have some affordances here as well. If we mistype the option, we're going to get this error which says, so unknown option this, did you mean the actual thing? And we can do this exactly because we keep track of all of the options that are on the request. So this is the list. And again, if you write custom steps, maybe they accept options. So there is an API to register these options with rec so that it sees them. Okay, so one of the features that I wanted to, like one of the stories with rec I wanted to have is around testing. So maybe you are familiar with Bypass. It's a very nice library which allows you to basically use the plug contract, so it's the con, and kind of basically set like a canned response, a mock created like a mock response. So we support this with rec as well. Basically, we can do this. So let's save this off as a fake, and let's add this plug option here. And now what is going to happen is, let's remove everything. Now instead of hitting the network, rec is just going to hit the plug. So this is pretty useful for tests. Another way to test. So again, maybe you are integrating with third-party API, you want to have a count response in tests. What we can actually use is the adapters. So I mentioned we have the custom adapter, pluggable adapters. Finch is the default one, but you can write your own. So let's write our own. Instead of con, we'll take request. And what we're going to do is return request response tuple. And for the response, let's just create maybe something like this. Yeah. And typo here. Yeah, Boji. Nice. All right, I think we are good. So we have this adapter, and if you remember the slides about the contract, adapter is just a step. It's just a request step, and the only kind of special thing about it is that rec will make sure it is the very last step. So if you, again, the testing story, if you happen to be working with JSON APIs, maybe you want to return like a mock JSON. So there is a little JSON function here. And we would get the appropriate header, content type, application JSON, we would get the body. So the body is already decoded because rec does so by default. So we can set the raw true option to not do any decoding. So in fact, we got over the wire the JSON body. Okay, so these are like the basics. These are basically the built-in steps. And I quickly wanted to show, so basically when you write new custom steps, to make them even easier to use by others, you can package them up as plugins. And there isn't really like a plugin abstraction. A contract is just a convention. But let's actually see that. So we're going to remove all of this. And let's hit the Elixir Lang website. Okay, so we got the HTML. And now let's add a rec easy HTML plugin. So this is just a small plugin that I wrote. And what it does is, okay, let's execute this. we attach the plugin. And again, this is purely by convention. Attaching the attach function just adds appropriate steps. And now what we're gonna get is this easy HTML struct. It basically parsed all of the HTML, and now it happens to have a custom inspect implementation, so it's pretty printed, and it also implements the access behavior, so we can do CSS queries. There is an H5 element in there, so we can check it out. We have the Elixir tagline. Let's quickly check out another plugin. So there is a rec S3. Let's execute it. Let's attach it. And what we can now do. So yeah, notice that attaching the plugin doesn't really do any work. It should basically plugins should trigger on a particular thing, like maybe particular URL or particular set of options. And the S3 one is exactly that. So there is this OSCI datasets bucket on S3, which contains some training data for machine learning. And with this plugin, we can just use the S3 custom scheme. And what we're gonna get is actually the list of objects in this bucket. So this is kind of this. This is what the plugin does. This is like a little convenience to check out the stuff on S3. And we can of course hit get the actual object. Yeah, so there are other plugins. There is a BigQuery integration and Athena by my colleague Ale. I wrote some stuff for Hex as well. We probably don't have time to show the GitHub one, but yeah. So going back to the presentation. So again, stretching the library, what are the missing batteries? I want to add cookie support. I want to add request streaming, which is pretty trivial, but I want to do it only when I know how to do response streaming, which is not. So basically the problem is that I have this abstraction in these steps, and it is not yet clear to me how to basically fit chunked responses into them. But yeah, before shipping 1.0, I want to solve all of these problems. And I was planning to do a comparison with other HTTP clients, but I don't think I could I could do them justice in a short talk like this. So if you want to talk about maybe some comparisons, I'm happy to do this afterwards. And these are the URLs. And thanks for your time.